Hello everybody, I'm back in the shop again. I should have called it the Dusty Shop. I figured I'd come out here today and do a 3D carve. First thing I got to do is convert my table back over from a plasma to a router. So let's get this thing converted back to a router table and let's get on with the 3D carve today. So when I set up this CNC to work with plasma, all I did was I modeled this little piece up here in Fusion 360 and 3D printed it just so I could hold the torch. And I keep these two screws right here just finger tight. I do not have a torch height controller, which wouldn't be that hard to set up on this system, but if this crashes down into the material, that'll pop up real easy. So that'll keep me from tearing anything up. I modeled this piece up in Fusion 360. I brought it into my slicer as two separate pieces. And that's all I did to hold the torch inside the spindle mount. Took about an hour to print on my old Ender 3. I actually got this file on Thingiverse actually. So it's really easy to convert your CNC router to a plasma. All you need is a relay switch to trigger the plasma torch coming off the laser contacts of the super long board. Just a little while back I did a short video of this palm router right here from Makita going bad. Everybody wondered why I had this little shim right here. That's just a little shim just to give a little bit of pressure on that switch right there, because when I first bought this router it worked just fine. It was not long at all before the vibration of the router started moving this dial up and down. So the more you ran this router, especially on a servicing bit, this dial would start to slow down. And I've seen some 3D prints on Thingiverse, and I've actually got the model myself and I've never really printed it. But all it does is it glues to the side here, and there's some teeth that just hold these grooves, and you can still spin it, but it has gives it a firmer register to click into these grooves, so your dial does not spin up and down. Well, I didn't do that. Matter of fact, just a few weeks before, just like 2 weeks before this router went up, I just took this piece of cherry shim right here and I just barely stuck it in there just to keep that dial from going up and down. Some people said, "Oh, look at what you done. You caused it to catch on fire." No, I did not cause that. I was not expecting that at all. I was surfacing a piece of wood. I don't know if you can hear that. I was surfacing a piece of wood and I heard the sound change. I heard it getting very rough. And I was just going to do a short clip of the sound it was making. I wasn't really trusting it anyway. I was not going to start another long carve with this router. And sure enough, as soon as I turned it on, you heard the sound, and then it just started blowing smoke, and then a flame shot out the top. So that was not staged, that was not planned. Dang sure I still haven't been able to replace this, so I don't know why I would try to tear up something that actually makes me money. But I saw a few comments of how I staged it, and spindles or routers won't ever do this, and bullcrap, whatever. Think what you want to. Keyboard warriors on YouTube love to start an argument, I guess. Anyway, as I said, I still have not replaced that. I went back to my old Harbor Freight Bauer. I've used this router on this machine for 3 years. It still works. The only reason I bought the Makita is everybody raved about how good it was. Now that I got the router in here, I will lock this down with my Allen key. But everybody was raving about how good the Makita was, so I figured I'd go ahead and get one. The Bauer router does have its drawbacks. It is slow to spin up. When you put it in a piece of wood, it will slow down and then catch back up. It will not hold a constant RPM. I know on the Bauer, that variable dial has never moved from where I set it. So it's more firm than the Makita. I'm not going to lock this down real tight. I might forget about it, but I'm probably going to need to adjust this after I get my spoil board put back on. The reason I have this hole cut in the center of my router is strictly for the plasma. You don't want plasma shooting directly down onto the wood. You will start a fire. I have a couple of different spoil boards for this router. I have a finishing spoil board and I have this roughing board right here. It's just a piece of plywood. This one has been well used. Cutting out a lot of these catch-all trays, and I have not been surfacing that wood, and it is not a consistent thickness. So I've dug into this board pretty good bit. I plan on this probably taking about 4 or 5 hours for this carve. This 3D carve is going to be about 13 by 16. That's my standard go-to material. Depending on the STL, I'll keep it somewhat in ratio for the STL. On my Bible carve, I don't know if you've seen any of the 3D carves I do of the Bible. It's just the open book STL from Vectric VCarve. It is in their clip art library. I use that to create a Bible, and I'll laser engrave the text, whatever text someone wants into it. One of those I actually did for a grandmother. She had a lot of grandkids. I can't remember exactly how many, but each of her grandkids' favorite verse was engraved into that Bible. And I did it using the grandkids' own handwriting, except for one of them. One of them was way too small. They had a favorite Bible verse, but it was not old enough to actually write it themselves. But she did put her signature at the bottom of it. I think it was her mother actually wrote it out and she signed it. But I did all those Bible scriptures. Let's bring up my RDP. That address is 45. Wait a minute. Cap locks? Yes. You know what? That's not going to blame work. You know why? Somebody unplugged the Wi-Fi card. Please check your internet connection. Where is my internet? I don't know. It shows I got Wi-Fi. What card are you using? Was it 145? It's 145. Duh. Yes, 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 and yes. I've never remoted into this particular computer from down in the shop. Hello? Is anyone at freaking home? What in the crap is going on there? It did not remove the. I'm gonna have to plug up that other Wi-Fi card. I got a poor signal. Oh yeah, 1 bar. Where is my Wi-Fi card? There you are. See down here, I had a very poor signal. I was connected to the internal Wi-Fi on this mini PC. I bought an Alpha card. I got it up in the loft of this building. So if I go over here and connect to the second card, that gives me a lot better signal. That's the one I have here. Gosh knows I don't remember paying that much for it. That's the one I have. But if you're having trouble with Wi-Fi in your shop because it's so far from the house, this right here, you can get this. It plugs into your USB port, and you can set this up in your loft. It's dual band, 2.45 gig. This will, yeah, you can suction cup it to a window or something, but I don't use that. Sometimes I keep it up in the loft, and this will give you a lot better range on your Wi-Fi. I've got one at my office that's only got 2 antennas. I bought it a while back, and I've actually got a Yagi that will connect to one of those antenna ports as well, and that's a directional antenna, and you can get up to 2 miles of range depending on how high you set that antenna. But that right there is the Wi-Fi card that I use in the shop. So you can unscrew them antennas, and that Yagi would screw into the small SMA right there. Anyway, squirrel. Now, back to what I was doing. RDP. I'm not going to get anything done today, am I? 145. Yes. Much, much faster. Where are those? Those are over here. This is the computer that's in my laser room in the basement. Project photos. Bible carves. That's it right there. This is the Bible I done in those grandkids' own handwriting. Anyway, like I said, I use the open book model inside of Vectric. When I first started doing them, I cut the Bible completely out. And actually, I had an individual bring me a piece of wood. He said he bought a block of wood from up in the mountains, and he wanted me to do something special with it. He told me he purchased this for a pretty good bit of money. This is it right here. This is the first Bible that I carved in a piece of wood that someone brought me. This piece of wood had live edge on both sides, on both ends. So I did not want to lose all of that live edge. I didn't want to waste all of this wood. So this is also the first Bible that I did with a base, not cutting the book completely out. And I started doing that from then on. I liked it a lot more. He absolutely loved it, although there is a big flaw in it right here. And if you watch my video on creating this Bible, you will see what that flaw is and what I did to fix that. And just looking at this video, tell me if you can explain where this flaw is in the top of this Bible and what happened. But that's in a video I did when I was creating this. He absolutely loved it, and I started doing it that way ever since. When I did this Bible, the model, I stretched the model up just a little bit. I was trying to get all the text to fit. And it just so happened the dimensions of this was 11 inches tall, 16 inches long. So that's where I started calling this my 1611 Bible. And for those of you that don't know, 1611 is the King James Canon. That's where we get our King James Bible. It's from the 1611 manuscripts. I didn't put that together until much later on that I did those dimensions 16 by 11. Moving on. I think I'm going to put this one together from scratch so we can go through the workflow of VCarve Pro and bringing in an STL and creating this carve. Before I create the file, I want to look at my material. I've done cut a few pieces off of this board. This is cherry. You know what? That would take for freaking ever if I did. How long would that take? How big would this be? Let's find that out first. Let me grab me a tape measure. This one right here, this is 15 3/4. So my material is 15 3/4 inches wide. If I do 15.75, and you cannot see what crap I'm doing. On my job setup page, if I do 15.75 inches wide to match my material, that is 42.5 inches long. I'm definitely not using all that, but we'll go ahead and put the dimensions in anyway, just for craps and giggles. I fat fingered a 0 in there. There we go. There's my board. I'm just going to hit, oh no, what did I hit 2 inches thick? Because this is a true 2 inches thick. I've got 0.001 inches in there for my thickness right now, and that is the dimensions I use when I design for my plasma cutter. So there's my material setup. People get on to me for not entering the proper dimensions of my material, but hey, it does not matter. Let's bring in our STL. I'm going to file, I'm going to import my component / 3D model. That is on my desktop. So let's go to my desktop. Cowboy lineman is what I'm wanting to bring in. It comes in imperial measurements. It comes in 45 inches wide and 300 inches tall, 296 inches tall. Yeah, no. Let's scale that down. It says 1.79 inches thick. I'll make it 15 inches wide. That brings it to 23 inches tall. We'll apply that. It's already centered to the material, so I don't have to click center model, but I did anyway. You may, sometimes it's off to the side, so you want to click center model, and that will bring it to the center of your material. I'm going to click position, and you can see right there that would cut off the whole bottom of the model. I don't want that. I'm going to bring this slider all the way down anyway, and I'm just going to click import. Brings my model right here. I'm in 3D mode or view. So let's move out to 2D view. I'm going to click it. I'm going to click it again, and that gives me my dimension handles. I'm going to click it in the center, and I'm going to bring it to the bottom here. There. Now, if I did that this tall, I forgot how tall it said it would be. One thing I do need to do anyway is put a boundary box around this model. So I'm going to select that boundary. I'm going to select the model, and then I want to click this button over here to create vector boundary around selected component. When I do that, it puts me a little rectangle around my STL over here. Now, of course, I could have done that by hand, but if you have a very complex model, like an eagle or something, and you got all those wings around it, you just select this right here, and that will create your, we'll show you in a minute how we use that vector. But for right now, I just want to click that. I'm going to click our ruler. See, I'm not perfectly straight, but that's okay. If I take 24 inches, well, if I take 23 inches out of the top of this thing, this is going to be a huge, yeah, I don't want to do that. Let's go this way like I always do. I'm going to make 15.5 my height. We'll turn this material 90 degrees. That would be a very large and very nice carve, but that takes too long. It's going to take up too much material. This right here is not a cheap piece of wood. If I'd done something that big, I'd have to charge so much for it. Wouldn't nobody buy it anyway, probably. And I still need this to make some more Bibles with. So let's not do that. Go back into my material, my height. I'm going to change my height to 15 inches. I can select all of this. That's going to select my, when I click up here and drag down, that's going to cover the entire workspace. That's going to select my model and that vector. If I click to, if I start on the right hand and click up and just barely cover those two, it's still going to select everything. If I start from the left and click come down and drag over, it's not going to select anything. That's because when you start from the left and come down to the right, you have to cover everything that you want to select. You start from the right and go to the left, you can just barely cover what you want, and it will grab. And I'll click again, and that will give me my boundary handles. And we could just drag that down to scale it to whatever size we want. Now, if we're in our 3D view and I click the model, we get our boundary handles, but I also get these numbers. And if I just click one of these handles, those numbers stay. Double click the top, and we'll set this in 3D view. If you grab one of those boundary handles, you can drag it up until you see the desired dimensions. It tells us right here that's going to be 1.2796 inches thick. And if I select my model, hold my shift, and select my vector as well, and then click on one of the handles, just one single left click, the numbers will stay. And if I double click inside of here, it's going to select all of these numbers, and I can just type 15 and I hit enter. And that's going to scale everything Vectric does have a tool over here to scale your models, but it's just as easy to come into 3D view. You can even do it in 2D view, but in 3D view, we've got our dimensions right there. Just type in what you want. You don't have to worry about what you got, where you want it to be. Just type in the size that you want, and it'll scale everything accordingly. Now that we have this scaled to our material, make sure that we are on our material. Go back to 2D view. I'm going to select this. I'm going to click it and make sure I am tight in the bottom. I don't want to do that. You know what I want to do? I want to draw this back just a hair. I'm going to make this just a bit smaller. And I don't even know how much smaller yet, because I want to do something on this one that I normally do on my cars like this. Bring it down a little bit more. I'm just eyeballing this right now. I think right there may look good. This is going to be a lot thinner than what happens if I bring it out just a hair. That don't look too bad. You don't want to drag this out too far. It'll really start distorting. So you can do a little bit of manipulations with your STL within Vectric VCarve without having a spire. And to that point, you can control how thick this will be. You can control some of the dimensions. But see, if you come way out here, that's just going to look weird. I think I can get away with that much distortion right there. I do that. Drag it. I want to scale it down just a bit more. Scoot it over just a hair. Now, what I plan on doing here, I'm just going to click over here just to deselect everything. I want to click my vector, and I'm going to do an offset. I'm going to do an outward offset. Am I going to do an inch? No, I'm not going to do an inch. Control Z, I'm going to do a 0.75. 0.75 actually fits. I'm going to do an offset of 0.75 or 3/4 inches, and that's going to be our cutout. This is just going to make a frame around our 3D model. That's what I'm doing right here. So now, when I cut this, I'm going to go to 3D view. I'm going to select my vector. I'm going to click this corner right here, and I can see that this needs to be 14.8271 inches tall and 11.814 inches wide. So that's going to determine how I cut this piece of material. I know I've got 15 3/4 inches, so that's going to give me plenty on the height. That's going to be this way, 11.81. That's just under 12 inches. If I do 12 inches, it's not going to have a lot of meat holding on the side for my clamps. I don't have to worry about that as much. The top and the bottom are going to hold it pretty well. I don't think that's going to go anywhere. It's still going to have some tabs. I'm going to run with it. You know what? Just to be on the safe side, I'm actually going to do at least 12.25 inches, just to make sure I got a little bit of meat on the sides for the clamps to hold the material. So let's cut this 12.25 inches. Let me go get my framing square. That's still going to be a beefy carve right there. All right, my Milwaukee saw does not like this thick cherry material, so I'm going to break out the old Makita. You see how thick this is? I'm definitely going to have to raise that spindle. These are clamps that I designed. Takes 2 pins, goes in there, and it registers to a grid of holes in your spoil board. I use those on my MDF board. And this piece of plywood, I just put a piece of scrap wood down against my stock, pop it down into the spoil board. This right here's got a taper to it, so you got a good beefy edge pressing up against your material. It's thinner right here, so you can screw and go in further and get some more bite on your spoil board. And since the screw is lower, you don't have to worry about running into it with your bit. The more bite you get into the spoil board, the more it will pull into your material and give it a good hold. And these little scrap pieces do not have to be anything special, just as long as it will hold a screw. That will go nowhere. I'm just going to move the router down. It's going to hit the wood. Let me back out just a hair so you can see what I'm doing. The router bit has hit the wood, and I'm still moving my router down some. You can see the router's not moving, just the mount. So don't have this tightened up quite yet. Got it really loose. I think I like it right about there, so I'm going to lock it down. It's in normal, so I'm going to move that back up. I'm going to scoot that to the side. We'll move that down. And I don't know if you can see right there, my bit is touching the spoil board, but the collet nut is not touching the material yet. That's telling me that I will be able to make it all the way through this material without bottoming out my Z-axis while the bit is still making complete contact with the spoil board and not crashing the nut into the top of the material. A couple key points. So now that I like that, I'm going to go ahead and change out this bit. I got a couple of new bits from IDC Woodcraft. I 3D printed these little holders that hold on my bits right here. Very handy, right here out front. So you can grab a bit as you need them. They're right here. Now I just need to make me some models where I can slide my wrenches in sideways. I want them in sideways because I don't want them sticking above the meat of the spoil board. I want to make sure that the collet is clean. I want to make sure there's no sawdust inside of the collet nut. You do not want that. Your bits will slip. I'm going to insert my finishing bit. This is not the ultrafine. This is just the fine bit from IDC. I've got an ultrafine, I think, but I've never used that thing. I don't do smaller carves. It would come in handy for a smaller carve, but it takes these bigger carves way too long to finish with the ultrafine bit with not that much of a gain. What I'm going to do now is I'm going to navigate the tip of this to the corner of my material, and I'm going to plunge that into the corner, and I'm going to set that as home. That's going to be my 0 point. If I lose power, if anything goes wrong, I can bring that back to my hole that I made in this material, and I can re-zero it to that spot. This is how I do my homing. So let's get this over here. Every once in a while, maybe not all the time, every once in a while, you're going to want to make sure your router's plugged into the wall. We're going to start that up. All right. Nothing huge, nothing deep. It's just got a little spot right there. It's deep enough that it's going to stay there throughout the entire carve, and it's something I can register my home point from. In gSender, now that I have my bit set to the corner where I want it, I'm just going to zero up everything. Precise. I'm going to set this back to normal. I'm going to raise my Z. I'm going to change this back out for my roughing bit. I'm going to put my hand on this bit so it just does not fall out. And I'm going to squeeze my 2 wrenches together, not using the button on the side of the router to hold the spindle while you're cranking on it with this wrench. What is up with all these spiders today? There's another one right there walking across my material. You need to move, little buddy. That is not a good place to be. I'll be glad you're not in the laser. Go away. You need to go. Okay. Maybe he won't get hit. He fell down on the side of there beside the stock. I made me an order the other day. I got the 1.5" surfacing bit. I got me a 1" bowl bit to replace my old one. And I got me a new hog bit. I like the hog bit. I don't care much for the beast. I don't care much for the badger. I do thicker carves, so I need a longer, more rigid bit. I'm going to use my new hog bit to rough this out right now. Make sure you're not extending your bits in your collet, trying to get a little bit more reach. The reach you gain will cause you problems later. I'm going to home my X and Y. Then we're going to zero the Z axis. I got my magnet stuck to the side of the chuck. Got my plate on the stock. I'm going to drop that just a few times. Then I'm going to hit my probe button. I'm going to touch the probe to the bit ever so gently. I get my green light. I'm going to press start probe. All right, my material is set up. The bowl bit does have a wax coating that you can peel off before you put it in your router. You just peel that right off. That was one of the questions on the last IDC Live. What do you do with that coating that's on your bit? You just peel that right off. You'll see the bit's real oily. That's to keep it from rusting. I'm going to grab it by the edge away from the cutters. I'm just going to press it back. All these fell out of my holders, I guess, in shipment, so they were just rattling around inside the containers. I'm going to cover that back up. I'm going to set it over here with the surfacing bit. Let's prep our file now. I haven't not prepped our file yet. Back in VCarve. This is set the way I want it, so let's go into our toolpath area. Hold your shift and select that. With those two vectors selected, I would do a pocket, and I would set that pocket just slightly lower than the top of the 3D model, and that gives it the appearance that the model is taller than it really is. I'm going to go ahead and program that in this one. I don't know if I'm going to do that or not. But before I can do that, I need to see how tall this is going to be. So I'll do that first. With the model selected, we're going to go for our roughing pass. Our roughing pass is going to be done with a 1/4 inch hog bit. I'm just going to leave it at the 1/4 inch in mill settings. I'm going to carve to this boundary we made earlier. Remember, I clicked on this model and we told it to create a vector around our component. Well, this is where we're going to use that vector. Material boundary? No, that would make it carve all the way out here to the edge. Model boundary? That would make it carve all the way to the edge of the model. In this case, that could work, but I always like to have this vector, and I will hit selected vectors. That way it will carve all the way to this vector. I always do that for all my models. You get, like I said earlier, if you've got an eagle with wings and such, you could use this, or you could have an offset around it that you carve to, depending on how you want your end product to look. I call this my cowboy lineman. Cowboy rough is what I'm going to call this toolpath. All right, now that that toolpath is calculated, we can hit preview. It carves a good bit before it actually starts into the model itself. I do not want that, so we're going to change that. We've got a material setup over here. I want to enter my material setup, and we can see right here our model is sitting at the bottom of the material. I want that model. Sometimes you might want it just below the top of the material. I want it all the way to the top of the material. I want to save as much of the bottom of this material as I can. You can use some of this to your advantage if you would like. You can come in here and you can actually make that model just a little deeper so it stands out just a little bit more. I'm not going to mess with that today. All right, now that I've got my model set to the top of my material, it's going to automatically change my toolpath for me. Now, let's play that. Now it's redone. I'm going to, let's see, undo last. Now you see on that first pass of roughing, we had some detail. So this is gonna, for one, it's gonna take a lot less time to carve. For two, it's gonna be a heavier product at the end because you're not taking as much material away to begin with. Now let's do our finishing pass. Tapered ball nose. You see IDC has two tapered ball noses. One is for ultra fine detail, and the other one, the tip on one is 0.015 degree, the tip on the other one is 0.045 degree. The 0.045 is what I want. It's not the ultra fine, but it is plenty detailed enough for a large carve. We're going to go with selected vector. In our 2D view, we need to make sure that that vector is indeed selected, and we can calculate from there. Now let's preview that toolpath. Now you can start from the center and work your way out. This actually carves faster. Sometimes it may leave a little witness mark in an X fashion where the bit comes down, stops, comes over, stops, comes up, stops, comes over, stops. Every one of those little stops leaves a little bit of a witness mark that can be taken out very easily. But that will actually carve faster because you're not traversing the entire model throughout the entire carve. All right, with our tool paths set, the only other thing I need to do is I want to select here, and this will be a profile. I'm going to cut to the outside of that profile. I got this set to plasma. I got a special tool bit in here I named plasma. It's got all the dimensions for that. I need to remove that. Calculate that. You see how that is going to turn out. And we can start the router up and send her on her way. Router is set to 2.5. Let's start it up and see what's going to happen. I'm going to start this really slow to start off with. That's too slow. Oh my goodness, that is clean. That is a clean cut right there. And we'll hit start. good enough. Be doing any 3D carving. These things right here are pretty good about getting in there and taking all those little fuzzies out. Get a whole box full of them. And after just a hit a clear coat, I'm going to let this dry. It'll probably take about 3 more coats of clear. It soaks up into that wood. There's our carve. All right. Thanks for watching. You'll stay tuned for the next one.